If you look at Jupiter through a small telescope, one feature immediately stands out. A gigantic red oval swirling across the planet's surface. For more than 300 years, astronomers have watched it rage without stopping. A storm so enormous that the entire Earth could disappear inside it. This is the Great Red Spot, the largest and longest-lasting storm ever observed in the solar system. And despite centuries of study, scientists are still trying to understand how something so violent can survive for so long. On Earth, hurricanes eventually die. Even the most powerful storms collapse within days or weeks. But Jupiter's storm has endured for centuries. It is a hurricane that never ends, a rotating vortex larger than planets. A storm driven not by oceans or continents, but by the terrifying physics of a gas giant. To understand why the Great Red Spot exists at all, we first need to understand Jupiter itself. Because Jupiter is not a planet like Earth, it has no solid surface. No continents, no oceans, no land for storms to crash into. Instead, Jupiter is a massive sphere of gas, mostly hydrogen and helium, wrapped in deep layers of atmosphere, thousands of kilometers thick. Beneath those clouds, the pressure rises so dramatically that hydrogen begins to behave like liquid metal. But far above that metallic ocean lies the visible atmosphere, the layer where Jupiter's storms are born. This atmosphere is divided into colorful bands that circle the entire planet. Light-colored zones, dark belts, these bands move in opposite directions at incredible speeds. Some winds exceed 400 kilometers per hour. And where these high-speed streams collide, they generate enormous turbulence. On Earth, storms are powered by heat from warm oceans. On Jupiter, storms are powered by something far more immense, the planet itself. Jupiter radiates more heat than it receives from the Sun. Deep within its interior, gravitational pressure slowly compresses the planet, releasing enormous amounts of energy. This heat rises upward through the atmosphere, feeding gigantic convection currents. Warm gas rises, cool gas sinks. And when those flows interact with Jupiter's powerful jet streams, enormous storms begin to form. Among those storms, one became the most powerful of them all. The Great Red Spot. The first recorded observation of this storm dates back to the 1600s. Early astronomers using primitive telescopes noticed a large reddish oval drifting across Jupiter's atmosphere. At first they assumed it was temporary. But decades passed, then centuries, and the storm never disappeared. In the late 19th century, measurements revealed that the Great Red Spot was enormous. At that time it was nearly 40,000 kilometers wide. More than 3 times the diameter of Earth. Since then, the storm has gradually shrunk. Today, it measures roughly 16,000 kilometers across. Still large enough to swallow our entire planet. But its persistence is even more remarkable than its size. The Great Red Spot is a massive anticyclone. On Earth, cyclones rotate around low pressure. Anticyclones rotate around high pressure. The difference is subtle, but the physics is profound. Inside the Great Red Spot, gases spiral around a central high-pressure region. Winds reach speeds of over 430 kilometers per hour. Cloud tops tower kilometers above the surrounding atmosphere. From space, the storm resembles a gigantic rotating eye embedded in Jupiter's striped atmosphere. Yet unlike hurricanes on Earth, this storm never makes landfall. There are no continents to weaken it, no mountains to disrupt its circulation. Instead, the storm floats freely within Jupiter's atmosphere, trapped between powerful jet streams that act like invisible walls. These jets prevent the storm from drifting north or south. They confine it to a narrow band around the planet. And within that band, the storm continues spinning endlessly. But there is another reason the Great Red Spot survives: energy. Storms on Earth lose energy quickly. They depend on warm ocean water to keep spinning. Once they move over land or colder water, they weaken and collapse. The Great Red Spot has no such limitation. Jupiter's atmosphere constantly feeds it. Smaller storms form nearby and are absorbed by the larger vortex. When these storms merge with the Great Red Spot, they inject fresh energy into the system. In effect, the storm feeds on other storms. Astronomers have observed this process many times. Small white ovals drifting through Jupiter's clouds eventually collide with the Great Red Spot. Instead of destroying the storm, These collisions strengthen it. The vortex swallows the smaller systems like a cosmic predator. But despite its power, the storm is not eternal. Recent observations suggest the Great Red Spot is slowly shrinking. In the late 19th century, it was enormous. Today, it is about one-third that size. Scientists are still debating why. One possibility is that Jupiter's atmospheric circulation is changing. Another is that the storm is losing energy faster than it gains it. Yet, even in its reduced state, the Great Red Spot remains the most powerful storm ever recorded. To truly appreciate its scale, imagine standing on a spacecraft high above Jupiter's cloud tops. Below you stretches an endless ocean of swirling clouds. Bands of orange, cream, and brown wrap around the planet like gigantic rivers in the sky. And then you see it, a vast red vortex rotating slowly across the atmosphere. Clouds spiral around its edge like massive storm walls. Lightning flashes deep within its turbulent layers. Winds howl at speeds faster than jet aircraft. And the storm stretches so far that the curvature of Jupiter becomes visible across its width. If Earth were placed inside that storm, it would vanish, the entire planet swallowed by the vortex. But the most terrifying aspect of the Great Red Spot is not its size, it is its depth. For many years scientists assumed the storm was relatively shallow, perhaps only a few hundred kilometers deep. But new measurements from NASA's Juno spacecraft revealed something astonishing. The storm extends at least 500 kilometers downward into Jupiter's atmosphere. Possibly much deeper. That means the Great Red Spot is not just a surface feature. It is a gigantic atmospheric structure reaching far into the planet's turbulent interior. A storm column larger than anything Earth has ever experienced. And the deeper scientists look into Jupiter's atmosphere, the stranger things become. Jupiter is constantly generating storms. Some appear suddenly and vanish within weeks. Others grow into enormous swirling systems. Occasionally these storms merge, forming temporary megavortices. But none have matched the persistence of the Great Red Spot. For centuries it has endured. A permanent scar in Jupiter's atmosphere, yet the storm may not last forever. Over the past few decades, astronomers have noticed subtle changes. The storm is becoming more circular. Its color is shifting, and its size continues to shrink. No one knows exactly what will happen next. It could survive for centuries more. Or it could slowly fade away within the next 100 years. If that happens, humanity may witness the end of one of the most extraordinary natural phenomena in the solar system. But even if the Great Red Spot disappears, Jupiter will remain a world of storms beyond imagination. Because Jupiter itself is a storm, a planet where the atmosphere never rests. Where winds roar faster than any hurricane on Earth, where lightning storms rage across entire continents of clouds, and where the physics of a gas giant creates weather systems that dwarf everything we know. The Great Red Spot is not just a storm, it is a window into the violent dynamics of planetary atmospheres. A reminder that the forces shaping our solar system operate on scales far beyond human experience. And perhaps most importantly, it shows us that weather, something we experience every day on Earth, can become something far more terrifying on other worlds. A storm that never ends, a vortex that devours planets. A hurricane that has raged longer than the United States has existed, still spinning, still roaring, still visible through even the smallest telescope pointed toward Jupiter. Waiting there in the clouds of the largest planet in our solar system, a red eye staring back into space.